Oh, student stride here again. Today you're going to be taking notes on section 11.2, stoichiometry calculations. Objectives list a sequence of steps used in solving stoichiometric problems and solve stoichiometric problems as the main objective. To be able to do this one, you'll have to be able to do the first one. Review vocab. You know what a chemical reaction is, process in which the atoms of one or more substances rearrange to form different substances. Main idea for section 11.2. Solution to every stoichiometry problem requires a balanced chemical equation. So we always start with that balanced chemical equation. As just mentioned, all stoichiometric calculations been balanced chemical equations, such as this one. We deal essentially with a few different kinds of problems: mole to mole, mole to mass, mass to mass. So they're all really the same thing. Our basic steps are we're going to write a balanced chemical equation. If you start with mass, first step will be to convert it to moles. Then once you have it in terms of moles, you convert moles of the given substance into moles of the unknown. And then the last step will be to convert moles of unknown to grams of unknown using the molar mass. Those are basic steps. In class, we will do a lot of conversion problems, but these are going to be your basic steps we're going to do. A little example, we have carbon dioxide gas, lithium hydroxide solid, yields lithium carbonate, a solid. Here we start with 20 moles of CO2 per day, and we want to know how many moles of LiOH would be required to maintain 2 astronauts in a spacecraft for 3 days. So first I have to have a balanced chemical equation. Then we want to figure out the moles of our given substance. So we got 20 moles per person. 2 people gives us 40 moles per day times 3 days. So we got 120 moles of CO2. Then we use a little conversion factor. And we're trying to get it into LiOH, so we look at 2 LiOH for every 1 mole of CO2. As we do these in class, I will expand out a little bit on how we write these out. But moles cancel the moles, and we do a little multiplying. And we get 120 times 2, 240 moles of LiOH. That's our basic process we'll be going through. Now, preceding problem, if we would have wanted grams, then we'd just use molar mass and switch it back to grams. And we will do a lot of practice on these in class. Chemical reaction. A chemical reaction equation must be balanced to make stoichiometry calculations. Very key idea. We have to have balanced chemical equations. How many moles of CO2 will be produced in the following reaction if the initial line of reaction was 0.5 moles? So we've got 0.5 moles of the NaHCO3, and we use a little molar conversion, And we want to know how many moles of CO2 from our equation. We got 1 mole CO2 for every 2 moles of the sodium bicarbonate. 2 moles of the NaHCO3. Moles cancel the moles here. And we just do a 0.5 divided by 2 is where the 0.25 comes from. So, that's a brief introduction into stoichiometry calculations. We'll practice a lot more in class. That's all for now.